Now, for those who are out, welcome back, welcome back, welcome back. I'm Lisa Blackburn. This is my YouTube channel for everything I like to talk about science and math. And today we are continuing the notes for Unit 2 in chemistry class about atoms and the periodic table. And we just talked about in the last video Rutherford's gold foil experiment, how incredibly shocking it was. And now we're going to talk about our next person, who is Niels Bohr. I like all these names, Niels. Nobody's named Niels anymore. Do y'all know any Niels? There used to be an old British comedy show called The Young Ones. I don't know if it's clean enough for y'all to watch, but so that's my, but it's very funny. And there's a guy named Neil in it. Neil. Okay. So Niels Bohr, he was the next one. And this was 1913. And he figured out that the electrons don't really just rotate around the nucleus the way the planets rotate around the sun. Instead, they can only hang out in certain energy levels. The electrons can start off at one energy level, and then they can get excited and hop up to other energy levels, and then they can hop back down again. Planets never hop between orbitals, do they? Earth gets a little tired of Earth's orbital and decides to go do Mars's orbital, right? No, that doesn't happen. But the electrons do. They can get excited and go into a different orbital than their orbital. Do you understand what he came up with? Okay, so it's this. It is the electrons only hang out in certain energy levels. The abbreviation in science for energy is a capital E. So put a capital E there, and if you need to in parentheses write that that's energy. The electrons jump between levels, and that jump takes a certain amount of energy that is called a quantum. Have you ever heard of quantum physics, a quantum leap? There used to be an old TV show with a time traveler in the 90s, I'm thinking, called Quantum Leap. I never saw it, but my students used to really like it. And I don't know if it has anything to do with Niels Bohr and his theory. Do you have a question, or you just poked your markers up? Okay, making sure. Okay, so this is what he came up with. And from it, we got the Bohr model. So now the nucleus is here in the middle, and the electrons hang out on these energy levels going around it. And they can hop between, but notice there's no stairs between the levels. They have to hop. And that hop is called a quantum leap. We're going to do a whole unit on just the idea of the electrons, how they're arranged in the atom, and how they can hop around. So that's all we're going to learn about this in this unit, but we're going to do a whole nother unit where we're going to learn all about it. I think it's the next unit we're going to do. It's very fun. Okay, so that's called the Bohr model. And you are going to be making Bohr models for this test. So with a Bohr model, you write how many protons and neutrons are in the nucleus, and then you tell how many electrons are in each level going around it. And I'm going to teach you how to do that. All right, so far? You're okay with that knowledge? All right. Next idea was the Joly, Curie, and Chadwick. Okay, so there was a very, very famous scientist. Her name, we finally get to a girl, yay! Her name is Marie Curie. And so all of these things were being discovered at the turn of the last century, the early 1900s, okay? So Marie Curie was a Polish-born girl who then went to France, because that was the center of knowledge in science at that time, to study at the university. She was the first woman to study at certain places, and so they started discovering radioactivity. And we're going to talk a little bit about how they did that. But she was studying radioactivity, and she got married to Pierre Curie, and they had kids. They had daughters. Well, one of their daughter is Irene Curie, and later, so we're putting what Marie and Pierre did away for a minute. We're going to come back to them. But we were jumping ahead to their daughter, Irene, and her husband, and they were able to figure out about the atom, that there was another particle that nobody knew about. that we knew about protons because of the positive in the ray gun. We knew about electrons because the atom as a whole is neutral, so there had to be a negative to balance the positive, or else atoms would be positive. And they figured out there was another subatomic particle. Do y'all know what it is? The neutron, yes. We should be doing the neutron dance. Do y'all remember that song? There's a song called the Neutron Dance. Okay. So they discovered there's another particle the same size as a proton but neutral. So Marie Curie's daughter, another woman scientist, came up with the neutron. Same size as a proton. Electrons are much smaller, but this is the same size of a proton but neutral. Okay, so that was our next big advancement. Yay. And then came another fella. His name is Heisenberg, and he refined it a little bit more to the electron cloud model and quantum theory. And this is really our modern view. We're still adding to it constantly, but this is sort of where we are now. And that it has a couple of things to it. Electrons are little bitty particles, but they can behave like a particle or like a wave. Yes, a particle or a wave. So they can be thought of particles or waves. And we'll talk about the experiment that proved that. There's several of them, but one of them. And also they figured out that there is a relationship between electron energy and light. Electron energy and light. Okay, so where we know that is just like the light bulb. Electricity, electrons are moving in wires. They're moving through the wires. They get to the filament where there's resistance, and they can change from being an electron. Now, I'm oversimplifying this, but this is a fine way to think of it. It's like they have a little superpower and they can say Shazam, I'm sure they say Shazam, right? And change from an electron to a photon, a packet of light, and go flying off through the room as light energy. So they have the particle nature in the wire as the little electron moving along as electricity. But then they have the wave nature when they can fly off as a photon of light also. Now there's more to it than that, and we'll learn more. And really, everything we learn in high school chemistry, you'll learn in college chemistry. There's more to it than that, and we're still learning there's more to everything. All right, so it has a dual nature. Now, it's not just light that you see. Light in science is the whole, what's called the electromagnetic spectrum. Okay, so the visible light is Roy G. Biv, right? Red, orange, yellow, green, blue, indigo, violet. Roy G. Biv. Everybody learned that, right? There's a song. Roy G. Biv is a colorful man at the rainbow's end. Y'all know that one from They Might Be Giants? Somebody did? See, there's always somebody who had, as a kid, that They Might Be Giant science thing. Anyway, we might have to hear They Might Be Giants instead of me singing. Okay, well, the whole electromagnetic spectrum, it's all the same, but there's just one little part of it that we can see, which is the visible spectrum. But there's a whole bunch of it that we can't see. And just like how we can remember that the visible spectrum is Roy G. Biv, we have a way to remember the whole spectrum, and it's Ronald McDonald is very ugly, extra gross. Ronald McDonald is very ugly, extra gross. And what it stands for, Ronald is radio waves. So we can write this down. R is radio, R-A-D-I-O. McDonald is microwaves. See if I can fit it in here. Microwaves. Is infrared. F-R-A. Infrared. You've heard of all of these, haven't you? V is visible. U is UV. Extra doesn't really start with an E. It's an X. It's X-rays. Come on, right. And gross is gamma rays. You know what turns Bruce Banner into the Hulk. Hulk smash. Gamma rays. All right, so that's the whole electromagnetic spectrum. That's all the light. The light we can see and the light we can't see. The light the bees can see. Yes, Camden. U is UV. You know, the kind that gives you skin cancer and a tan, the sunburn, UV. Infrared is heat. You can feel infrared. There are animals that can see infrared and UV. They can see more than we can see. We can only see the visible. So that's kind of weird, isn't it? To think there's colors that animals can see that we can't. But we can see like more than a dog can see, so we can take comfort in that, right? All right, and there's things we can hear that other animals can hear things we can't hear. Like elephants make sounds lower than we can hear. Dogs can hear things higher than we can hear. All right, so the whole electromagnetic spectrum is given off by these electrons. What happens is they will jump up to a level. They'll have a lot of extra energy because they've jumped up, and then they want to jump back down again, and they give off that extra energy as light. And that we're going to learn about that in our video tomorrow. I know y'all can't wait. And then we're going to be doing a lot of labs, and we're going to do a whole unit on it. Okay, so the next thing that we want to talk about, we're going to leave the story of the atom for a little bit. We're going to come back to it when we talk more about radiation. We'll come back to Marie Curie and Pierre Curie and some of these people. But right now we want to talk about, well, where did the periodic table come from? The most important thing, I think, in any classroom for learning, I believe, is the teacher. I know I'm a little... So here is the electron cloud model. There are these clouds that the electrons can hang out in. More than just the levels, there's these clouds that we're going to learn about in our other unit, okay? With Heisenberg. Oh, and the other thing about Heisenberg, I didn't tell you. I got to go back and tell you this. Okay, so Heisenberg is famous for his uncertainty principle. What he figured out was that when electrons move along, you cannot find out at the same time their speed and location. That if you find out their speed, you've stopped them and you don't have their correct location anymore. And if you have their location, you messed it up where you don't have their speed anymore. So it's called the Heisenberg uncertainty principle. You can't know everything about an electron. You can find out some things or other things. You can't find out about everything at once. Are you okay with that idea? Can you imagine it? Okay, so that was his idea. Okay, the next one is the periodic table. How did we get it? Okay, so the most important thing I think in any classroom is the teacher. The teacher doesn't need a smart board. A teacher doesn't need books. A good teacher can teach without anything else. But I think that the most important thing in any science lab, the most important piece of equipment we have in science is the periodic table. And we are really at a handicap because ours is covered up right now, because physical science just had their test on it. Okay. What? Yes, we do have a little one right here. That over there is a Bohr model. I'm going to be teaching you how to use that. So yeah, we got one right here we can look at. All right, so there's the periodic table. And where did it come from? Well, it turns out that there's a guy. Remember I told you that there were a lot of the early church fathers who were religious people, pastors, monks, all this sort of stuff. This fella, not so much. His name was Dmitry Mendeleev. He was Russian, and he was a college student, a grad student, and he liked to play cards, which was very scandalous at the time, and he liked to drink vodka, a little scandalous too, and go to the bar. So we can all imagine our grad student with his cards and his vodka at the bar, right? Well, he noticed that there were patterns in the elements. He started noticing like that chlorine and fluorine are a lot alike, and that maybe calcium is like other metals, things like that. He started noticing that there were these patterns in the elements. Did he put the patterns in the elements? No. Did he invent the patterns of the elements? No. He discovered the periodic table. He did not invent the periodic table. He discovered it because the patterns were always there. So what he did is he took his playing cards and he wrote on them what was known about each element. And he would move them around and try to find how to arrange them by the patterns. So there are repeating predictable patterns if you arrange the elements correctly. So he would arrange them and rearrange them and rearrange them, and finally he got them all arranged by atomic weight. That was before they taught you did things in mass. They called it atomic weight, same thing on Earth. And he got it all arranged, and he discovered the periodic table. The periodic table. Now, when he did it, he shocked the scientific world because he got them all arranged, but all the elements hadn't been discovered yet. He was able to leave spaces for ones that weren't discovered, and he said, this is going to be discovered. It's going to have these properties. It's going to have this weight. It's going to do like this when it does chemical reactions. And then, as they started discovering them, and he was right, ooh, it was like he was psychic, but he used science to predict the future with his periodic table. Okay, got that? All right, so the next one is Henry Mosley. He was another young guy, imagine young guy, British this time, and it's right before World War I. Okay, he's in England. He's brilliant. They say that he was probably more brilliant than Einstein. He's probably the most brilliant scientist who has ever lived. Why haven't you heard his name before today? You'll see. He figured out that Mendeleev had it wrong, close but no cigar, because at this time they didn't know, when Mendeleev did it, they didn't know about the proton. The proton is what gives atoms their atomic number. See these whole numbers right here? That's the number of protons. So Mendeleev had arranged it by this decimal number, the mass. Henry Mosley figured out it was wrong, that there's a real periodic table. Remember, it was discovered, not invented. And he rearranged it by the atomic number, by the number of protons. And that is the right way. Tells you how many protons. Then World War I broke out, and Henry Mosley got drafted. And all the professors who understood that Henry Mosley was the smartest person they had ever met, smarter than them and their professors in England, and they wrote letters to the government and said, no, he is the greatest treasure in England. He cannot go to war. So what do you think the government did? They sent him anyway. Did they give him a nice desk job somewhere? No, sent him right to the front lines. What happened to him? Immediately killed. Then, of course, people just had the biggest fit ever. And so there's a law in England now that if you're a brilliant scientist, you don't go to the combat areas of war. You get to go do something else. Because, like, once they killed him, they realized, whoops, too late. But they say he was probably more brilliant than Einstein. That's pretty shocking, isn't it? And sad. So, of course, the only pictures of him, and there he is, all young and baby face, because he was like 22. All right. So, new law. So, there's Dmitri Mendeleev's playing cards. The new law, we're not going to kill our scientists anymore in England. Now, I don't know about the U.S. I don't know what our law is. Okay. So then there was a guy named Glenn Seaborg, and he was alive not long ago. I don't know if he's still alive. I don't know if he made it through the COVID. But I know he was alive like in the 90s, 80s and 90s. But he rearranged it again. So you can see that this is, but he did it when he was younger. You can see that we're getting to real, modern history almost. But he is the one who figured out, see this part down here on the bottom? He figured out that those needed to be pulled out. So he rearranged it again with the actinides and lanthanides. Let me see how I wrote this. With the bottom pulled out is what I wrote. I knew that was too little of a blank for what I wanted to say. And the bottom section is the actinides and the lanthanides. Lanthanides, the actinides and lanthanides pulled out. Okay, now I told you we were coming back to more scientists. On the test, you have to match people to their model of the atom. You have to match people to what they did. You have to match people to something that you can remember them by. So you got to know these scientists. Okay, so here's our next one, Henry Becquerel. He accidentally discovered radioactivity. A lot of stuff in science was discovered accidentally. But you know, but they didn't. But they wrote stuff down, and then they looked at it by what I call their scientific glasses, to where when something happened accidentally, they thought, that's weird. Let's figure that out, and then they did. Not just stopping with, that's weird, but figuring out why it happened. So what happened with him is he had some glow-in-the-dark rocks, okay? And he was doing experiments with glow-in-the-dark. We're going to pause this.